Okay, so this is the lab for the activation module for 430. So there's a good bit of reading here, and I'm not going to sit here and read it all for you, so you should read all that yourself. This is the main setup for the problem, so this is the code here that we're going to be executing, and there are three main questions, and we'll answer sort of all of them at the same time as we step through the code. So the first question is, what does the stack look like when we reach this location, so this statement here. When we reach this statement here, which if you kind of read ahead a little bit is kind of the deepest point of our call stack, and then we're asking what is the output of the program. So let's go ahead and answer the first one, which is sort of the easiest one. So what I'm going to do is I'm going to draw all this off to the side here because there's quite a bit to draw, and I want to make sure that I have enough space. So we're going to start with our stack, and we're going to kind of go with the way the book draws these, which is drawing the stack growing upwards. As you may remember from 261, it's more traditional to draw them growing, at least on the x86 side, to draw them going down, because then you have the high addresses at the top, but we'll just stick with the book's form for this. So the first thing we need is a stack frame for the program itself, or P, and because P doesn't really have any of these things here, except for local variables, there's not really going to be anything in there. So nothing called P, so there are no parameters, there's no return address, there are no static or dynamic links. So really the only thing in the stack frame for P is just a local variable, and we can see from the code that it's called int, or it's called x, it's an int, and we are not given an initial value for it. So you could denote types here if you want. I'm just going to make it a little bit cleaner by leaving them out. So this is the stack frame for the program. Okay, so as we execute the program, we set x to 3. So, okay, great. So now we can say that x is equal to 3. And now we call A. So now we're going to be creating a new stack frame for A. And so, you'll want to keep this sheet off to the side because it kind of gives you a quick reference to what the stack frames are going to look like. So as we start building the stack frame for A, we do have a return address, and we're going to be returning back to the same place where we called A, so that's line 31. Note that we're using line numbers here because we're tracing this in source code. Obviously, once this was compiled down to assembly code, this would be the address of the next machine code instruction. The reason we're using the same line number is because there might still be more things that need to be executed. So for instance, up here we need to make this call to F, and then we still have some things that we need to do on this line. And so we're going to return to the same line and just trust ourselves to make sure that we remember where we were coming from when we get back there. Obviously, this is not an issue with assembly code because you'd be returning to the next address. Okay, so we push the return address. So in calling A, we push the return address onto the stack. We set up the dynamic and static links, which at this point are both just pointing down to the program. We do not have a return value, so A is not a function, and we do not have any parameters. We do have some local variables though, so we have a local variable called A, we have a local variable called B, and we have a local variable called C. So this is A's stack frame. And I suppose off to the side here we could be noting where our pointers are. So when we started in P, our environment pointer, or the base pointer, I'm probably going to call it both of these throughout the course of the video. Environment pointer is what the textbook calls it. Base pointer is what we called it in 261. So in any case, the stack pointer was at the top of the stack frame, and the base pointer points at the base of the stack frame, which is why I prefer to call it the base pointer, but in any case, it's the same thing. So when we called into A, we had to adjust all of our pointers. So now the base pointer is pointing here, or the environment pointer. The stack pointer is pointing up there. So we'll kind of keep this up to date over here, but I'll probably forget to do that once or twice. So, all right, so it's not crucial to answering any of the questions. So Now we're in A, and so we should look at what's going on in A. So we have the declarations up here that we've already handled. We have declarations of F and G, which we don't need right now. And then we have some code. So here's the stuff we actually have to run. So A equals X plus 1. So we have an A. So the question is, where is the X? So we don't have any X inside of a stack frame. So where do we go looking for it? Well, we're told that this is a statically typed language, so we follow the static links, which take us down to the stack frame for P, and we find that we have an X there. So that's great. So now we can use that value for X here. So we can now set A equal to 3 plus 1, which is 4. We can set B equal to X plus X, which is 3 plus 3, which is 6. And then we can set C to X minus 1, which is going to be 2. Okay, and now we are at location 1. And so what I've drawn here is the answer for problem 1.